Hey, good morning, everybody. This is Mr. Ainsworth. We're going to get into your Section 3 homework here in Unit 5 here in AP Pre-Calc. All right, here at Great Oak High School. So let's do it. All right, number one, the function B gives the temperature of Boston. So it's a temperature function. I guess B for Boston here. All right, B of T, where on a particular day where T is measured in hours. Okay, so you have to understand the units of the problem here. So T is in hours. If I could even spell. All right, it's early in the morning. All right, and then this is temperature of Boston. Okay, so it's a temperature function. All right, T hours after midnight. Is B 1 to 1? How do you know? Okay, well, in this case, when you take a look at the temperature over a particular period of time, it is possible for the temperature to go up and down. Okay, so if I just drew a little sketch here. So we got T is number of hours here. So after midnight, and up here we have B of T, the temperature. It is possible to have the temperature fluctuate. So it could be, I don't care what the units are, it could be here at 1 hour after midnight, and then up here, and then here, then here, then over time, it could be the same temperature right there, same temperature, and then it might go up. It could be the same temperature as that. So even though the temperature fluctuates, it's possible to have the same temperature at different times of the day. And that is not a 1-1 function because it fails the horizontal line test. Okay, horizontal line test. So I'm going to say no. All right, the temperature during the day, we have to explain in words here. So temp during the day. Might be the same. Okay, at 2 or more different times after midnight. So at 2 or more, because it only takes 2, but it could be at 2 more different times during the day after midnight. All right, not only that, it fails the horizontal line test, okay? Visually, that's how you tell. Fails the horizontal line test, as I just illustrated to the left. Okay, so there's a nice little illustration there. All right, number 2, the function's given here on the interval from -6 to 6. Okay, so this is your domain of the function. All right, notice it's -6 here. Notice it's +6 here, and there is your domain. And then asking you here, is f 1 to 1? Well, based upon what I just said just a minute ago, all right, it's not, okay, because it fails the horizontal line test a bunch of times. Okay, I don't care where you draw a horizontal line. If you can draw a horizontal line anywhere, and it intersects the graph at more than 1 point, it fails. And it's not 1 to 1. So it fails the horizontal line test. What does that mean? Okay, well, so here's the implication. This arrow means implies. So it implies, that's what the arrow means typically. All right, it's not 1 to 1. Okay, not 1 to 1. Okay, so the function does not have an inverse. That's what not 1 to 1 means. Okay, that implies, okay, f inverse, all right, is not a function. Is not a function. That's what it means. That's what it implies. Didn't ask that, but I'm telling you that because you need to know that. Okay, when it's not 1 to 1, that means f inverse does not exist and it's not a function. You'd have to actually restrict the domain for that to happen. All right, in order to make it 1 to 1. We talked about that in the lesson. All right, here they ask you to find the inverse. Okay, so there's a couple steps here. All right, step 1. All right, switch variables. Switch x and y. I just usually say switch vars. Okay, so you're gonna start off with x is equal to the square root of y plus 3. We actually did this multiple times in class. And then step 2. All right, you solve for the original variable. So in this case, the original variable is y. All right, so let's do that. Let's square both sides. So you get x squared is equal to y plus 3. You square both sides. Okay, and then you subtract 3. So simple. And so you get x squared minus 3 is equal to y. And then you write it in the correct notation. Y inverse is equal to x squared minus 3. Okay? This symbol right here means inverse, as you guys know. All right, so we do not say y to the negative 1 power. If you hear anybody say that, just say no. All right, that's not what it is. You say y inverse, okay? Y inverse or f inverse or whatever the function's called, right? All right, just took a sip of my coffee there because it's early in the morning. As you guys know, if you ever watch my videos, I do run these things at crazy times during the day. Okay, so number 4, given this function here, find the domain of f inverse, okay? F inverse, and it is possible to do this without finding the expression. Okay, and the answer is yes, okay? So what we do is we find the domain of the original function first, okay? So the domain of the original function is all reals except -5 because you can't divide by 0. All right, and this is a reciprocal function. Let's see here. Let me just draw a little sketch here. Now there's vertical asymptote here. That's a vertical asymptote at -5. So I'm going to sketch it at -5, and then the function. You know what the parent looks like, so you know what this looks like. It looks like this. And if you don't believe me, just go ahead and do what we always do, is we either bust out the T84, or in this class we have technology, and then you just type it in. So y equals 1 divided by x plus 5. All right, and you can see what I'm talking about here. Type in the x, the vertical asymptote. All this stuff, you guys, we do in class. Okay, so look at that. So I just sketched the function here on the left, and there it is on the right. Okay, so I'm just gonna screenshot this bad boy, bring it in. All right. All this stuff we do in class. So you should be good at it. And so let's bring this in. All right, so there you go. And then let's see here. But you don't even need the graph here, guys, and you don't need to find the inverse, okay? You just need to know the domain, which is all reals except -5, and then the range, if you look at it here, the function can't be equal to 0. Y can't be equal to 0 because it doesn't hit the x-axis. So y cannot be equal to 0. All right, and then it says, is it possible to do this without, or is it possible to find the domain and range of f inverse without finding the inverse? And I'm going to say yes, because all you have to do is switch. So yes. All right, just switch the domain and the range of the original function, okay? Just switch. All right, the domain and range, okay, of the original function to get the domain and range of f inverse. So here we go. So for f inverse of x, even though I haven't found this yet, all right, the domain, all right, is all reals not equal to 0. All reals not equal to 0. The range is all reals not equal to -5. And if you want to verify that, well, go ahead and then go ahead and find f inverse, and you'll see what I'm talking about. But again, I just take these right here, switch variables, and switch domain and range, and voila, you get the domain and range of the inverse. Because the range of the original function becomes the domain of the inverse. That's why. Okay? All right. Number 5. Table of selected values is given as a 1-to-1 function. Okay, cool. At x equals -5, it has a vertical asymptote. Okay, so there's your vertical asymptote here. And then what in the world's going on here? Okay, so if it's 1 to 1, that means f has an inverse. So that's what that tells me. So f inverse exists. Okay, it exists. Okay, and is a function. That's what this information tells me about 1 to 1. All right, and then let's read the problem here. So what does it ask? So part A, what is the y-intercept of G inverse? Okay, so this is your x value, this is your y value. Okay, on f inverse, all right, this becomes 0, 6 because you switch variables, as I keep saying. So switch variables, and guess what? That's a y-intercept of the inverse. Oh, not f, but g. Okay, the name of this function is g, so let me switch that. So G inverse, okay? And so this one right here, pretty straightforward here. All right, the y-intercept is 0, 6. All right, you write the equation of the horizontal asymptote of G inverse. Well, guess what? You take the vertical asymptote and you switch variables, and guess what? Here, x equals -5 becomes y equals -5. It becomes a horizontal asymptote, okay, HA for short. And that's it, all right? Because we switch variables, guys. It's not that hard. Okay, number 6. The graph of the f of x is shown. Give the domain and range of its inverse. Okay, so again, this is like repeated questions right through here. You got to switch the domain and range. All right, switch domain and also the range. So if I know the domain and range of the f, then I know the domain and range of f inverse. So what I do first is I write the domain and range of the original function. So let's do that. Just by looking at the graph right here, I see a vertical asymptote. So there's a vertical asymptote at x equals 2. So the domain is x is not equal to 2, because obviously the function doesn't hit that. It's an asymptote, right? And then I also see a horizontal asymptote at y equals 4. And so the range, if just by looking at here, the function never hits the horizontal asymptote either. So it's all y values, or all reals, all y values not equal to 4. So you look at your asymptotes to determine your domain and range. Then, this is of f of x now, okay? This is the original function. Now for f inverse, that's different. You got to switch the domain and range, as I keep on saying. Okay, and so the domain here of the inverse function is, x. Let me back up. So the range of the original function becomes the domain of the inverse function. So it's all reals except 4. Okay, and then the range here becomes all reals not equal to 2. All right, and there we go. You switch variables again. You switched the domain and range, as I've probably said about 5 to 10 times already in this homework set. Okay, number 7. Explain how you could restrict. Okay, so here we go. We did this in the lesson. All right, how can you restrict this domain so that it's 1 to 1? Well, here's the deal. I would suggest, just to get an idea of this, is to do a little sketch. All right, so I know a right here is -2, so it opens down. So I'm using my prior knowledge from previous units. I know by looking at this right here, which is in vertex form, this is a times x minus h to the second power plus k. Okay, it's called vertex form. We talked about that in prior units. So this is just one of those things that you guys have to know. Okay, so we want to restrict the domain so that it's 1 to 1. So, because right now it's not 1 to 1. And the reason why is because of this. So let's sketch the graph. Okay, so the vertex here, the vertex is h comma k. So v, h comma k. In this case, the vertex is 4 comma 5. And it opens down. So all you have to do is go 1, 2, 3, 4, 5. 4. 1, 2, 3, 4, and then up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, there we go. All right, so there's your vertex at 4 comma 5. It opens down, so here's your sketch. And all you need is a sketch, okay? All right, now it's not 1-to-1 because it fails the horizontal line test, so we need to restrict the domain, okay? Restrict the domain so that it is 1-to-1, so that it does have an inverse. And all you do is take either the left half or the right half. So I'm gonna highlight the right half. So let's go right half here. And then let's write that out. Okay, so the right half here, if I choose to take this right here, the domain would be, it's from 4 to infinity, right? So 4 to infinity. Or you can say x greater than or equal to 4. And that's all there is to it. And then if you do that, it'll pass the horizontal line test because the horizontal line will only intersect once. Or, if you want, you could take the left half as well. Okay, if you take the left half as another opportunity, I suppose, the domain would look different. Okay, it would be from negative infinity to 4. So from negative infinity to 4, or you can say x less than or equal to 4. Okay, so that's the left half idea. So there's two different ways to do it. Either use the left half or right half, and what you want to do is you want to split it right down the middle through the vertex. Okay, remember, right through the vertex. So again, take it to the right or take it to the left. All right, number 8. What's going on with this one here? So the graph of h is shown. So this is function h here. All right, graph the inverse on the blank coordinate grid, which means below. So we want to graph the inverse down here. Okay, no problem there. So here's the idea. So any coordinate on f of x, let's just call it x comma y, all right, becomes y comma x on the inverse. Okay, so you want to switch coordinates, as I keep on saying. Okay, all right, so let's do it. So I got point A here, I got point B, I got point C, and I got point D. Now point A is at, looks like 4 comma 11, 4 comma 11. B is at 0 comma 7. C, it looks like 3 comma negative 2. D looks like 5 comma negative 3. All right, and then you switch the coordinates. All right, so A prime, so 11 comma 4. So 11 comma 4 would be up here, that would be A prime. Excuse me, this is a negative number, sorry. Negative 4 comma 11 becomes negative 11 comma negative 4, so let me redo that, sorry. So 11 comma negative 4 is down here. A prime. I'm using geometry notation here, so it's 11 comma negative 4. B prime, 7 comma 0. I'm just, you know what, forget the prime notation. I'm just gonna switch the coordinates, make it easy. All right, and that becomes 7 comma 0. C, negative 2 comma 3. It's up here. So negative 2 comma 3. D, negative 3 comma 5. And then you just connect. Okay, it's not that hard. Okay. Gotta put in the sound effects. Okay, and there you go. And that, my friends, is the inverse. Okay, inverse. All right, switch coordinates. Easy. All right, is that it? That's it. All right, that was a short homework set. All right, I'm Ainsworth here. And hopefully, I'll see you in class, and also seek to understand. All right, do your best and make sure you do your homework problems, because if you can't even do that, forget doing well on a test. So put your effort into your homework, and I'll see you in class. Take care. Bye-bye.